jump on the live stream now.
Cool. We've probably talked about all the stuff you just.
Yeah, no, we have nothing to talk about. Hi, everybody. Welcome to another meetup of the Data on Kubernetes community. I believe we are now in officially meetup number 63. Unofficially, we've already passed number 70. This is a really special one, and we're just getting warmed up and having a lot of interesting side conversations. But Matt Jarvis is no stranger to the camera. Just speaking about his past in working in film. One of not many people who studied film and actually worked in film for a while, and as a result got into technology. As usual, if you're not checking us out already on LinkedIn, Twitter, Slack, jump in. Always happy to get involved, continue the conversation, etc. Matt is also a CNCF ambassador, so we're kind of crossing paths on that.
I'm not a CNCF ambassador. I'm
not a CNCF ambassador.
CNCF ambassador,
an aspiring, a soon-to-be CNCF ambassador. I will definitely put in a good word for you. So we can cross paths there. Matt is a man who's worn many hats. Do not be confused if you go to Google and type in Matt Jarvis and you see a footballer who used to play for Millwall. There is no relation, apparently. Matt has done much cooler things than that, which we'll be getting into. The key topic today is cybersecurity, but I think there's going to be a way to tie in a lot of other things. As you see behind him, he also has a really cool record collection. I believe that's a film poster as well behind you to your right, if I'm not mistaken.
I have lots of it's some artwork, not film.
Okay, but it's some nice artwork. And then behind you to your left, also a nice little throwback, the Mesos Con, because you also had some experience in the Mesosphere.
I did, yeah.
Anyway, Matt, very big welcome to the Data on Kubernetes community. As usual, for all the folks that are attending, if you have questions, put them in the YouTube chat. We will get them. We'll get to them accordingly. But Matt, what are we going to talk about today? What's the deal? What's going on?
So, well, thank you for having me for a start. Yeah. It's awesome to be here. So we're going to talk a bit about Kubernetes security. Going to run through some kind of live exploit stuff, so we can kind of see how you can go from a single exploited container right through to losing control of the cluster.
Okay, with that in mind, though, just for a couple of things regarding the backstory, you've been working with Linux since the 90s. What was your first encounter with security? And, in terms of how things have changed over time, we were talking about how some things have changed significantly over time. If we're talking about content creation, if we're talking about TV series, because Matt worked on some TV series. But regarding cybersecurity, what was your first encounter? You were telling me about some modems that you were working with. What was the first time that you were like, hey, maybe there's something we need to, keep our eyes open?
Yeah, I mean, I guess for me, like I was telling you before we started the show, I started playing around with little single floppy Linuxes probably in about 93, 94, because I wanted to share. We'd got one of the first cable modems in the UK, and I wanted to share this internet connection with my housemates, and so that kind of blew me away. That you could I found an old 486 that I pulled out of a skip and stuck this floppy in it. And it was a router,
and it worked,
and it's routing packets, and you're like, well, this is fucking black magic, So all of a sudden we've got this, we've got a proper network, and I think what was super interesting when you started to have proper IP connections was just looking at what traffic was hitting you from the outside, right? And even back then, you just get a lot of exploratory stuff there. And I've done lots of different roles in terms of open source development over the last 20 years, and so I've run organizations providing services to large groups of development engineers, and so I then had to kind of go through the whole thing about getting stuff certified for particular certifications, and I ran a public cloud platform for a while. So as soon as you've got public facing services on the internet with real customers paying real money for you, it sort of sharpens the mind a bit about the potential for getting owned, so, and I just found myself over the last few years, I obviously been around the container world for a long time. I was at Mesosphere working on Mesos, and before that I was in the OpenStack community for a long time, so kind of been in the cloud world for a lot of years. And I found myself going to KubeCons and just becoming more and more interested in the security talks. Yeah. And so when the opportunity came along to work for Snyk, I was like, you know, actually, this is super interesting to me. But I mean, I think everybody who's in the container world has really noticed over the last 2 or 3 years that sort of the focus on security has become a lot keener. You know, I think when any technology space goes through massive adoption, you know, it kind of starts out a bit like the Wild West, and you know, it's especially when things are kind of led by developers, these movements that are led by developers, like the container space has been. That at some point in that adoption cycle, you know, you get adoption by big companies, and people start to really care more about security. But you know, I think security is a big topic at the minute anyway. I mean, we've seen this week, right, some more major ransomware attacks. Yeah. And you know, we've had so many big data leaks over the last few years, right? Which is
in supposedly in places, you know, that were too big to fail. Everything was just unthinkable to a lot of us. I think, and another thing that we get a lot as well too in this particular space in the Kubernetes world is, you know, the crypto factor of mining going on through clouds, things like that, you know, that all the major cloud providers have become aware of in the last year or so, that, you know, this is very much a thing, and that organizations have to keep that in mind. Going back to what you're mentioning about security becoming, you know, being more and more of a thing, you know, we talk a lot about, is it DevOps, is it SRE, et cetera. DevSecOps, is that really only for security people, or should that really be something embraced by everyone?
Well, I mean, I think the concept of DevSecOps is like, you know, is like the concept of DevOps, right? This is, when we look at security in the cloud native space, right? There's 2 key things for me that are driving why we need to look at security, right? So the first thing is, you know, like when I first got into professional computing, right? The aim of most computing environments was don't change anything. You know, like as little change as possible. We know where things are. We don't want to change, because change introduces uncertainty. And now we want to do the exact opposite of that. We want to change as often as possible, because velocity, development velocity, new features, and all that stuff, that's like, you know, you're going to live or die on that, right, as an organization. So we've got that one thing that, you know, we're all about CI/CD pipelines. We're all about super fast development cycles. So faster and faster iteration. The second thing is that we've gone from, if we look back, you know, a decade, developers were responsible for like a really small part of the stack, just the application. Everything else, like, you know, your virtual machine, your networks, your LUNs, for those of you who remember those kind of days, it's all done by somebody else, right? And deployment done by somebody else, you know. And what we've seen as we've moved to Kubernetes is like the space that the developers are responsible for has grown much more significantly, because you really can't separate out your application from the container image, right? When do you ever deploy the app without the container image? Never. So you may as well consider it part of the same thing. And you know, often those container images are being developed by the same team who are developing the app, and they are potentially developing the Kubernetes configuration to go along with that. So all of a sudden you've got the, like, developers own, you know, most of the stack in terms of getting that application to deployment. So that kind of changes the game from a security perspective, because we can't think of things anymore like in the old way of security, where we had this big step at the end, where like before something gets deployed, it goes to be audited or any of that stuff, right? So DevSecOps is really about that we build security or into the software development lifecycle all the way through the process. So, you know, we give developers tools to be able to both understand, but most importantly, action security stuff right at the place where they're working. So IDEs in the CLI, we build it into source code management, we build it into our container registries, we build it into our CI/CD pipelines. And so we have security as this sort of developer first integrated thing that is built into software, so that you know, we as we develop our software, we're doing security all the time. And I guess that's what the sort of the idea of DevSecOps is, that we kind of merge security into development and operations in exactly the same way that we merge development and operations together, you know, over the last decade. So that's the kind of idea.
I think it's a great point. Like you said, that the role of the developer has changed, and you've seen those changes over time. That about how, what does it really mean to be full stack? And we can say that, security is perhaps the added ingredient that might sometimes be forgotten there. And then when we're talking about Kubernetes, it's sometimes like, oh, this is a day 1, day 2, et cetera, et cetera. Let's talk about day 0 or even day -1. We've had, Jim Bugwadia from Nirmata on here talking about Kyverno. We've also had different conversations about Open Policy Agent. So, there are different, initiatives, open source projects that are out there to make people more aware and more conscious of this stuff so that it doesn't become something that this is only something we're going to add to our culture if it becomes a problem. If the price tag is big enough, then that's when it's going to become an issue. But it's really, and also, it's not about, cutting developers' wings. It's about putting the necessary guardrails so that they're working in the environment that they need to be working in, and not something where there are too many what ifs.
I think you see developers that really care about this stuff a lot more than they used to as well. I mean, we did some survey work just recently where we were asking developers from a whole range of organizations like how they felt about security, and they were like super focused on it. I think we kind of we need to give developers their props for really starting to think much more about these things. And I mean, because we have to consider it as one holistic thing as well, right? Because we also talked a little bit about some of the recent things that have gone on in the world of ransomware, and you were mentioning cryptocurrency mining and things like that. These things are all almost always a combination of a vulnerability in an application that gets you in the door, and then infrastructure misconfiguration, which allows you to expand the blast radius. If we look at all the major hacks there have been, the major data loss stuff, it's all the same pattern.
What they all have in common are those 2 factors.
So those 2 factors, yeah.
And speaking of which, isn't that what we're going to see today?
Yeah, I'll talk you through a kind of slightly mythologized kind of version.
Oh, I like mythology. I'm a big fan. You have an eager audience here.
Yeah, cool.
With that in mind too, I mean, without getting into too many details about Snyk, what is it that about their approach to security that you think is different perhaps than other companies that are out there? We talk about some companies that that are Kubernetes native. You also, coming from the Mesos period, have seen the development of these things in over time. So what do you think makes that unique in your current role?
So, I mean, Snyk are really all about this developer first idea. We start up from the product development perspective with the developer in mind. And, our first kind of major product was around open source package management. So looking at vulnerabilities in packages you're including in your application. And, again, that's something that's really targeted at developers. So giving developers those insights into like, what are you including here? Because this thing might have vulnerabilities in it, but also this thing's going to bring in these other 50 things that also might have vulnerabilities in them. And, we now do, container image scanning, we do code scanning, we do the whole range of stuff right up to production deployment. But it's all, the thing that ties it together is all this developer first thing. That's really where Snyk, where the Snyk journey started. And you can listen to lots of talks that Guy Pajani, who's our founder, has given, on the internet, where he talks about this very eloquently, about this idea of developer first, and but also about actionable stuff, because a lot of security comes from that thing of like, oh, here's this massive list of CVEs. And, if you're a developer, you're like, well, how do I make sense of that? Right. I mean, we've all seen it. I mean, when I was a sysadmin, it was hard enough to get your head around what all these different things were and what these vulnerabilities meant. And it's not really possible for you to have a deep understanding of all these vulnerabilities in all of these things and then make choices about that. So you need tools that are going to give you actionable insights. So they're going to be saying, here's how you fix this, and quite often you might not even really need to understand what all these vulnerabilities mean, right? Because if you can score them and prioritize them in the appropriate way, and have ways that you can automatically fix them, then so I mean, say there's something that's a high severity vulnerability and it's got a fix available. Well, that's pretty much a no-brainer. Just apply the fix, right? You don't even need to care about what that vulnerability is. And so we do things like automated fix PRs, where we'll integrate with source code management, raise PRs automatically against against dependencies that you've included in that. Or the same for Docker files, right?
Mm-hmm.
If your base image has 700 vulnerabilities in it, upgrade the base image, right? Here's another one. You're going to get 50 vulnerabilities in it. And so it's really about these actionable insights and making that friction free for developers.
Very, very good. Well, the main thing here is putting the developer at the center. I mean, I think
exactly.
that's quite clear.
Yeah,
and I think that's really good, so that it's empathy based, because I think too often security gets a bad reputation for like, oh, it's the FBI that's coming to audit, like you said, auditing these kind of old school, heavy duty paperwork sort of procedures that once again, why, of course, we're going to put that off to the very end, because nobody wants to do it. But rather than that, it's like, hey, let's have a dialogue about this. Let's see what's going on here. And let's see, like you said, vulnerabilities and misconfigurations. I think it's a great thing about the two factors there.
Yeah.
That being said, let's jump into your mythological presentation. I'm very
cool. Let's get this on the go. Just bear with me 1 second.
Not a problem at all. I will also ask later about cybersecurity films and TV series that you might recommend. I watched War Games with Matthew Broderick not too long ago.
One of my favorite films of all time.
I should say rewatched, but it's a great film.
Okay, right, let's go. Hopefully we might move some windows around here and make things a bit bigger and smaller as we go on, but let's kick off. So this is me, in this fine intro. Matt Jarvis, I'm a senior developer advocate at Snyk, and I've been building stuff with open source for a pretty long time, and I've worked, in ops, in development, and now in security. So, like I said a minute ago, almost all impactful exploits in the real world are a combination of application vulnerability giving you an initial opening together with system level misconfiguration, allowing the blast radius of that exploit to spread. And in today's kind of session, we're going to look at how this can play out in a fictional scenario in the context of a Kubernetes cluster. So where we're going to start is that we have a mocked up application with a remote command execution vulnerability. This is clearly a mock-up for the purposes of this demo, but there are lots of these in the real world, and that allow you to execute commands remotely on a machine. I was looking at one around Tomcat the other day that lets you do very similar things to this. But for the purpose of this demo, this is a mock-up. So where we're going to start is that I'm going to go through, where are we now? What do we know to start with? So all we know is that we've got this vulnerable web application that we found on the internet, and it's exposed on port 80, and we've connected to that. And let's also introduce our timeline of doom. So this is going to show where we've got to in terms of our exploit. So what can we do from here? So the first thing that we might do is that we know that when applications are running in containers, we can often get interesting information from our environment variables. So again, my mocked up application here is going to let me run arbitrary commands. So let's just get that link. So what I'm going to do here is to start with, I'm going to look at what environment variables there are running in this application. And this has told us lots of interesting information. Clearly, we are running in a Kubernetes cluster. We can see lots of references to Kubernetes. We can see an internal address of the API server. And we can see that we can assume that the pod running our application is exposing this port on a service at port 5000 that's then being ingressed somehow into our Kubernetes cluster. So we can update our timeline of Doom and add that we know we're running in a Kubernetes cluster, we know we're running in a pod, we know we have this service on port 5000, and we know the internal API of the API server. So let's see what we can find out about the network at this point. So what I'm going to do here is run IPA, and so we can see that we've got the IP address of the pod. So we're going to make a note of that because that's going to be interesting for us a little bit later in this demo. So we know what IP range our container is running in. So if we now go back to here, we can add that we know our IP address. So let's have a look what else we can do. So by default, every pod in a Kubernetes cluster has a service token auto-mounted in it. And this is associated with the service account that was used to create the pod. You can control this on the service account or pod level using auto-mount service token, service account token equals false. But you know, in lots of clusters, this is not the case. So let's see what whether we've got a token here. So you can see where we've looked for this token. This is where it's auto-mounted, and we can see we've actually got a token. So if we update our timeline of Doom here, we can see that the next thing that we've been able to do is access some credentials. We've accessed this pod token. It's available inside our pod. And so it's worth noting that the first two stages of this exploit we could also have done if this was just a directory traversal vulnerability where we might be able to escape out of the folder that our application is being served from, because we can also access all of these environment variables by catting this file from the proc file system. So let's see what we can get from the internal API server using that token that we just found. So what we're going to do here is connect from our internal IP address of the pod to the internal IP of the API server, and we'll again do that using our vulnerability here. So we can see we're using curl here. I'm going to take that token and we're going to take the CA cert that's associated with that token, and we're going to look at the internal API, and we're going to try and access this endpoints API. And so we can see we've had a response from that. And in the real world, this is a cluster that's just running on my laptop. In the real world, this would give us the external IP of the API server, which again is going to be very useful to us. And so because we're running in kind, I already know what the IP is of the API server. But this is in itself is a vulnerability because we've allowed that token to access the endpoints API. So I've been able to discover more things about the cluster from the API server itself. So now that I've actually got a token, what I'm going to do is I'm going to take this token and I'm going to now configure my local kubectl to use this token along with that external IP address of the API server. I've actually got a handy little script that will hopefully do this for me, but you could do this manually. So I know that my API server is going to be here. So let's make sure that is actually set. Okay, so the first thing that I'm now using the token that I discovered there, and we can see that the first thing I've tried to do here is to do kubectl get pods. I've got a shortcut set up here, but it's basically this command. And so we can see in the default namespace, I haven't been able to access anything with this token. But what's interesting is that it's given us a bit more information. It showed me that that token is namespaced to this secure namespace. So let's have a look and see whether in that namespace I can actually do something. So we've seen that I can actually get the pods that are running in this secure namespace using this token. And there actually is only one pod here. So we can make an assumption that this pod here is the pod running that vulnerable application. So let's see what permissions we've got in that namespace. And there's a couple of different ways that we can explore those permissions. Let's just make a bit of space here. So I can do kubectl auth can I --list token equals my token. And this is in the default namespace. I didn't specify the secure namespace. So we can see that we don't actually have many permissions at all in this default namespace. But if I now namespace that to my secure namespace, we can see that I have a bunch of permissions here on a whole set of resources. So I've got much more available permissions within this secure namespace than I do in the default namespace.
Oh, Matt, real quick, we got a question.
Yep.
As a developer, someone asking, as a developer, I included some packages to my application. At some point of time, a security tool detected a package that contains some infected files and vulnerabilities. How can I replace those once they are infected?
Well, I mean, in the container world, that would be a case of change whatever your included dependency was to an upgraded version. You know, most scanners, including Snyk, will tell you which package version to upgrade to get rid of that vulnerability, and then rebuild and redeploy. You know, kill all of your running instances of that app that are running in your cluster, and then deploy new ones. You know, that's the typical pattern in the container world.
Okay, and then the follow-up to that is, how can I go fast with more vulnerabilities ahead while using a DevOps environment?
You'll have to repeat that question. But
yeah, no worries. I'm not sure if it's entirely worded as they wanted it to, but I think you probably answered it with the first question anyway. So anyway, just continue.
Cool. Yep. Okay, we'll come back to that if you want to clarify that a bit later. So the other tool that we can use to look at our permissions is this kubectl plugin, Access Matrix. And I have this installed in my kubectl. And if we look at that default namespace again, you know, we can see I've hardly got any permissions in here. But if I look at the secure namespace, we can see I've got lots of permissions to do lots of things there. So if we go back to our slides here, so what do we now know? We found the external IP of the API server. And we know we've got these two namespaces. At the minute, we only know what's going on in the secure one. We know there is a default namespace. We don't know if there's anything running in it at the minute. We've really got an insecure role here. That's what we've discovered. This is a fairly typical pattern when people think that namespaces are actually a security boundary. So you might make an assumption that I'll deploy my application into its own namespace and I'll let the service account inside that namespace do whatever it wants in that namespace. And you know, that's probably it's not a very good decision from a security perspective, and namespaces aren't really security boundaries. So that's kind of what where we've got up to. So as we can see, we can add that to our timeline of doom, that our role gives that service account too many permissions in the namespace. So let's go back to our the pod that we know about, which is in our secure namespace. So let's now try and get a shell on this pod. So if I just copy that bit, and we can do kubectl exec it, our pod. It's in the secure namespace, and we're going to try and execute a bash shell. Right, so we've managed to get a shell on this pod now. So this is, if we look at the pod, so actually, you know, this isn't, I'm not running as root, so that's good, right? I've got this web admin user that's running my application, which seems to be the vulnerable application that we exploited. Let's try and see if we can raise our privileges and become root. And so we haven't even got sudo in this container. So, you know, from a security perspective, you might think, well, that's great. You know, I'm not giving anybody the opportunity to expand their privileges. So even if this is exploited, they're restricted in what they can do. Let's just try one more thing and see if we can create a file. So we can actually create a file there. And what that means is that potentially at this point, I could start downloading software into this container. I could change the configuration. I've already worked out that we have curl available, so that's definitely possible. And this is another vulnerability here, and this is caused by us not setting read-only root file system to true. And so if we allow the container to be read-write, like I said, it's going to allow an attacker to modify the container. And the way we protect against this is to configure the security context setting of our container. And we want to set read-only root file system equals true. There are not many real production situations where you do want to have things writing into your container. You know, if you need to store data, you've got external data stores for that. If you need to do logging, you've got, you know, distributed log systems for that. So, you know, it's good practice to have your containers in production set to read only. So we're not actually going to exploit that particular vulnerability at the minute. So let's come out of that container, and we're going to try a few more things to see what we can do. So let's try and spawn a pod running as root. And so if we, I've got some YAML here that we can test out. So here I've got some YAML that's just going to try and spawn a root pod. This is an Alpine container. It by default will run as root. So let's see if we can run that YAML and spawn a root pod in this particular environment. So let's try and do that in the secure namespace. So that looks like it's done something, but if we look at that namespace, we can see that actually we've got this create container config error when we tried to spawn this root pod. So let's have a look what's actually caused that. And if we do kdescribe pod root pod in the secure namespace, so we can see that that we've got some kind of policy here that is failing that from the kubelet. So we are not being allowed to run as root. There's something been set there that says we must be non-root, and that's probably a pod security policy. And because we've tried to run a container that's going to run as root by default, this has kind of blocked us from deploying as root. So let's try something different here. If we look at a different YAML here, we're going to run a non-root container, but we're going to try to see whether we can run with privileged equals true. And privileged equals true is obviously, that's kind of superpowers. That gives us lots of things that we can do in terms of mounting things on the host and all sorts of things. So let's just see whether that's going to work. So let's have demo YAMLs non-root privileged in the secure namespace. Right, so here we've failed straight away here because and our intuition was correct that we have a pod security policy in place here that is not letting me run privileged containers. So it's not letting me run root containers, and it's not letting me run privileged containers. So if we go back to our slides, we've learned some new things about our environment here. So we've learned that there's a pod security policy in place on this secure namespace. But does that stop us from extending our exploit? So let's try something different here. So I'm now going to try running a non-privileged non-root container. This is an image that I built, so it's going to pull from the internet. And I have some tools in this image that might be useful to me, but I'm not going to try and run it as root. I'm not going to try and run it privileged. So let's just apply this one and see what happens. In the secure namespace. So at this point, this looks very much like my pod is deploying. And we can see here that the container is creating. This is going to take a few seconds to deploy because it's pulling this container image. But what we've also learned here is that this cluster is not restricting me from pulling images from external repositories, which is another vulnerability because we can potentially pull things down from any repository that we might choose. So my pod is now running here, my Snyk pod, and in my Snyk pod, I know that I have a remote TTY program running. So, and I know that that's running on port 8080. So I'm going to port forward from my kubectl on my local machine. I'm going to port forward to this pod on port 8080. And what I can do now is I can go on my local machine and go to port 8080. And now I have a terminal again on my pod. And I mean, I could have connected to this pod via kubectl, but again, this is showing different approaches that you can use in terms of getting access to containers. So if I run who am I here, we can see I'm non-root, I'm this sneaky user. But interestingly, let's see what happens if I do sudo su and try to raise my privileges to root. And so I've been able in this pod, without running privilege, without running root, to escalate my privileges to root. And the problem here is that the pod security policy does not hasn't disallowed privilege escalation. And I've seen a lot of misleading documentation about this allow privilege escalation setting. That, oh, well, if you've got non-root set and you don't allow privileged containers, then this is redundant, but it's actually not. And I'll show you why in a second. But we can see in the pod security policy here that we've got this privileged false flag. We've got the must run as non-root. So the policy itself has been well thought out in terms of some of these things, but they've missed this allow privilege escalation equals false. And let's have a look at why that might be important. So if I go back to my normal user here, and let's just do if config and get some information about the network so we can see what the IP address is of this particular pod. So what I'm going to try and do is to try and map some of this network as my own user here. And I'm going to use the nmap tool, which I included in this image, pn --open 10.244.1.12/24. And straight away, if I'm non-root, this fails because it requires kernel level capabilities that are not included in this as a normal user. But if I sudo here, hopefully I should be able to copy and paste that. So now as a root user, because I've been able to escalate my privileges, I've been able to scan the network. So, and what I've discovered here is that, we know that our original, the original host that we exploited was on 10.244.1.9. because we had the IP address when we looked at the exploited application to start with. But what I've discovered here is another machine that we didn't know anything about, 10.244.1.10, which also has port 5000 open. Now, this is interesting to us. We had an exploit, we had an exploitable container that was running on port 5000 that was our initial into the cluster. So we've now discovered another host. So if we go back to our slides again, so we discovered that the pod security policy didn't disallow privilege escalation. That allowed us to escalate to root, and that allowed us to then map some of the network. So what do we now know? We now know that we have a machine somewhere that we've got an IP address for it. We don't know what namespace it's in, but we know it's on port 5000. So, and the other thing that we know here in our timeline of doom is that there were no network controls in place. So I was allowed to go from that pod that I launched myself. I was allowed to start scanning the network to be able to discover other things that were on the network. So let's go back to our compromise pod. So the next thing I'm going to do, because we discovered this machine on 10.244.1.10. I'm going to use SOCAT here to set up a tunnel from my Snyk pod to this other pod that we've just discovered. So we're going to do, we're going to listen on port 5001. We need reuse addr, we need fork, and we're going to make a connection to 10.244.1.10 on port 5000. Let's just background that. Oh, I've done that. Oh, I've got a space that shouldn't be there. Okay, there we go. Hopefully that's going to work. Yeah, we've only got one running. That's great. Right, so now let's come out of this pod, and we're going to stop port forwarding to our sneaky pod, and instead I'm going to port forward to this new port that we just set up that encrypted tunnel on, port 5001. So now what we can do is, if we go back to here and we go to localhost 5001, we discover that we've actually got another instance of that same vulnerable application. So we've obviously explored this application a little bit before. So let's have a look whether we've got a token in this new application that we just discovered. And we do, we have another token. So let's switch over our tokens now in our kubectl config and see what we can do with this new token. So if I let's have a look here. Let's just manually change my let's just comment out this one. So we've changed over our tokens. I'm just going to make sure that I've got that. I'm using that new kube config. So now let's try doing kubectl get pods. So this new token has given me permissions in the default namespace. So we'll remember that when we tried to run this command before, we had no permissions to look into this namespace. So we've been able to access this default namespace. Again, we can assume that this web admin is the application that we've just exploited. And again, we can look, check what permissions we actually have here using kauth cani, kubectl auth cani. And so we now see that in the default namespace, we've got a whole bunch of permissions that we didn't have before. So we've been able to expand the scope of our attack, and we now know that here's where we set up our encrypted tunnel from 5001 to port 5000, and we now know that this application actually lives in the default namespace. So let's now try and create a privilege pod in this namespace. So kubectl apply -f demo YAMLs non-root privileged. And in this namespace, it appears that I have the permissions to be able to create privileged pods here. So this namespace is clearly not restricted by that same pod security policy that we saw in the secure namespace. And with a privileged pod, we can actually do a lot more. So if we look at the YAML that I spawned that privileged pod with, what I've done here is actually mount the host root file system inside my container. We'll see what I can do with that in a second. But if we now get a shell on this host again, so we want to do kubectl exec it bin bash. So we've now got a shell on our new pod running in the default namespace. Oh no, we don't want that one. Sorry, it wants to be our privilege pod that we've just launched. Non-root priv. So we are now on our privileged pod. So let's escalate to root, which we know we can do. And so at this point, when I run the PS command and look at the processes available, what I'm seeing is the process table that's actually inside the container. So I'm only seeing the processes that are running containerized. But because I've got the host file system mounted here, I can use the chroot command, and I now have the host file system mounted as /. So when I look at the process table, I'm seeing all the processes on the host. So we can see here all the containerd processes that are running on the host that is running all those containers, including the kubelet, containerd, core DNS, all these other things that are running in the cluster. So effectively at this stage, we've owned the node. So as I've showed here in this slide, we've launched this privileged pod. We've been able to work out to access the host from here. And the problem was that the pod security policies that were in place on that secure namespace were not in place on the default namespace. So let's see what else we can do from here. Export. We're now on the host file system. Remember, so what we can do here is actually access the config of the kubelet, including the token that the kubelet is using. And handily, I have kubectl left in the host. So using the kubelet's token, I can now look and see the pods that are running in kube system, i.e. in the excuse me, sorry about that. They're running in kube system, which is the cluster namespace where all of the cluster control plane and things are all running. And we can also use that kubelet token to get the names of the nodes that are hosted in this cluster. And this is going to be important to us in a second. So at this point, probably you've really owned the cluster because you've got access to the node. But for the purposes of this demo, we'll go a little bit further in a different direction. Let's explore whether we can actually run pods, launch pods using the kubelet token. So from the node. So I'm going to just try and run a busybox pod here from the node. And as we can see, we can't, that token actually isn't allowed to launch pods directly on nodes. It is possible to launch a different attack here by, if we were to put YAML into etc. Kubernetes manifests on the nodes. There's nothing in that folder at the minute, but you can actually get the node to automatically launch pods. So that would be another angle of attack, another attack vector potentially against the control plane that we could attack from that thing. But because we've escaped the pod security policy and we know the name of the nodes, we're going to actually attack on a slightly different vector at this point. So we're going to launch a pod to the node that's hosting the etcd cluster. And so let's come out of this one. And let's demo YAMLs etcd client.yaml. So what we're going to do here is we're going to launch an etcd client pod, and we're going to launch it to the node that's running etcd. So we know, because we've been able to, we had the kubelet token, we can find the nodes, we can find the pods that are running in the kube system namespace. We're going to launch this onto the node that's running etcd. We know where the etcd configuration should be, so we're going to set some environment variables to configure this etcd client to join the etcd cluster directly from the node. And we're going to mount the etcd configuration. We know we can mount things on the host now in this default namespace. So let's go ahead and actually run that YAML. And if we look at kubectl pods here, we can see our etcd client pod is now starting. That's going to take a second or two to get running. So that's now running. So now let's just check whether we've managed to connect to the etcd cluster. And I'm going to exec a shell inside that pod, and we're going to run etcd member list, and we can see we're getting output here from showing us the members of that etcd cluster. So we've been able to connect to the etcd cluster. So if we look back to our diagram and see what's happened here, so we've launched an etcd pod and connected to the etcd cluster. And we've connected into that pod that's running in the etcd cluster is running in the kube system namespace. So now etcd contains a lot of interesting information about a Kubernetes cluster, not least of which is secrets. So let's see whether with our etcd client here we can actually access secrets from the etcd cluster on our Kubernetes cluster, and we can. And one secret in particular that we're very interested in is this cluster role aggregation controller token. And that token has cluster admin rights. It has the rights to change permissions for users in the cluster. So let's see if we can get that token. What's the string on the end is W-W5 GBH. And this has given us another token. So if we now take this token, which is this cluster role aggregation controller token, and we run that through kubectl auth cani --list token equals token. And as we expected, we have update permissions here on the cluster roles in the cluster. So really at this point, we've reached the end of our timeline of doom, because we now have a token that has rights to change permissions on accounts in the cluster. And it's kind of game over at this stage. We can pretty much do what we want. We can change we could change the permissions on different tokens, and we can pretty much do whatever we like. So how could we have prevented this? Well, obviously, clearly our first port of call was not to have that vulnerable application running to start with. And so scanning your application code, as we had that question right at the start about dependencies in your application code, giving vulnerabilities like this is clearly a slightly extreme one in the sense that it's a remote command execution vulnerability, but lots of these exist in the wild. If you're not scanning your application code and making sure those vulnerabilities aren't getting into your applications, then you've given an attacker that opening to be able to get in there and exploit the blast radius. The other thing I was able to do was to take advantage of small misconfigurations in your Kubernetes YAML in order to expand the things that I wanted to do. So the way that we prevent this is by scanning that YAML file, those YAML files, before you deploy them to production, so that you can identify potential security issues that are in there when you're setting your cluster up and when you're deploying your applications. And then the third thing is, excuse me, is to scan your container images. Clearly, if I'd have scanned that vulnerable web application, the image before it was being deployed, then I would have been able to pick that up. And you can do all three of these things using tools like Snyk. Obviously, other security tools are available as well. So I have to give massive props to some other folks in the Kubernetes security community. This talk was heavily influenced by Mark Manning, Ian Coldwater, Duffy Cooley, and to lots of others in the Kubernetes security community. So I hope that was interesting to folks. And
I think we can all agree it was. We got quite a few different questions. So first question is from Sarye. As always, thank you, Sarye, for the wonderful question. I feel that asking a developer to write a secure pod spec is too much configurations and knowledge. What is the best practice to enforce pod spec security configurations without requiring the developers to set them?
So, I mean, there's a number of ways that you can do that. And what some open policy agent and combined with things like Gatekeeper would be a great place to start. And what OPA and Gatekeeper will do will actually stop things from getting in if they don't have that policy created. You can also use things like webhooks, mutating webhooks, to be able to actually add those things into any pod spec that gets launched on your cluster. And some folks have workflows where those things are added in as part of your build process, for example. You can have some automation steps. Perhaps you give your developers a smaller subset of things that they need to set. And then as part of your build process, you have other things that are added to those Kubernetes YAML, that sort of fill them out as it's going through CI. So yes, there are lots of options there about different ways to do that. And I absolutely agree that a lot of the things in security context it's a little bit of a black art about understanding what some of them do.
Yeah.
I recently wrote a blog post about security context, and the documentation was really quite poor on some of them as well. I ended up having to go digging through the API spec to actually try and work out what some of those things do.
Yeah, I think it's not often that I hear someone say the documentation is too good on this one or too complete.
No, I think security context is definitely one of the places where it's easy to get confused.
Yeah. As a follow-up to that, because he mentions it, as you touched on, like using the admission controller and mutating the hook, but isn't that too much work to set up? But I think that you kind of addressed that. And then the second thing is couldn't there be something that's just secure out of the box? I think it's kind of what you were touching on with, OPA and Gatekeeper, but maybe something a little bit further from that.
So in what kind of sense? I mean, what at an application level, or?
Yeah. I mean,
so you can definitely make choices about your cluster deployments, right? I mean, at the end of the day, I'm usually working with vanilla upstream Kubernetes, right? And vanilla upstream Kubernetes is really about giving you as many options as possible, right? It's an incredibly powerful tool, but by default, it's not going to give you loads of guardrails because it's not designed to do that. It's designed for you to be able to make choices. So there are, resource limits aren't set by default. Well, that'll straight away let someone give DDoS your cluster, right? Because a pod can ask for as much resources as it wants until the kubelet runs out of resources. And Kubernetes that's not a bug. Like, it's a design feature. It's designed to be very general purpose. If you look at things like Red Hat OpenShift, lots of these things are built into OpenShift, because OpenShift is designed much more as a PaaS layer. And so, some of these things in terms of security, OpenShift will give you by default, as will other providers,
and of course there are other options, but it is true that very frequently in conversations, the words out of the box and OpenShift frequently seem to go together. Another question, and this may be a little bit tricky. In your professional opinion, if a company is suffering from ransomware, in every circumstance, do you think that they should pay, or that there are some circumstances where they say nope, not paying?
That's a very difficult question to answer, isn't it?
I imagine we'd probably just spend an entire meetup on that. You know what? Maybe that's the perfect excuse to think about a panel in the future. That's okay. Let's take a different one. No, this one is actually interesting too, because you having been working with Linux and then moving into the security space, also because all the names that you touched on, Ian Coldwater, Duffy, etc., the cloud native community and the hacker community, what similarities and differences would you say there are between the two?
I mean, I've been a part of a lot of different open source communities over the last 20 years, right? I mean, you know, clearly there's always differences between different communities. I think the Kubernetes community, particularly as it's grown, has definitely become very open towards new folks and folks joining. I mean, I know, you know, in the Kubernetes security and the CNCF community, security community, you know, is very welcoming to folks joining. I mean, you know, I think the days of some of the older open source communities of extremely had an extremely high level of technical expectation and sometimes some behaviors that probably in the modern world might not be appropriate, but you know,
such as
well, I mean, you know, there's been lots of controversy around the Linux kernel community over the years, you know. But I mean, you know, their communities trying to achieve very different things, right?
That's true.
I think it's always when you get very, very large open source communities, and we've really only had this probably 3 times in my lifetime, right? Linux kernel, OpenStack, Kubernetes. One of the biggest challenges is how do you make it feel like an open and inclusive environment that people want to contribute to, and how do you grow people's contribution from just being end user consumers through to you know, potentially being community contributors. And you know, I think in the cloud native space, we've done a pretty good job so far of being able to grow that community, and there are new folks joining all the time, and so yeah, I think things are working pretty well from that perspective. You know, you can always improve in terms of inclusivity and getting new folks into the community, but yeah, I think. I'm sorry, I've gone around the house.
No, but like you said, it's a question of objectives, and that's going to sort of condition the kind of environment and how folks are going to interact. One other question that we had here as a follow-up, because you know, we do interact a lot with the CNCF students group, and I think, you know, like I said, I don't think it's ever too early to get security into the equation when it comes to learning. Are there any resources that you recommend for beginners that are starting out with Kubernetes regarding security?
Yeah, so I mean the output from folks like CNCF SIG Security has been really good in terms of the white paper on cloud native security was really comprehensive in terms of identifying all of the things that you need to think about and how cloud native security differs from, you know, the previous generations of security. So I think that's a great place to start. I think getting involved with both the Kubernetes SIG Security and CNCF SIG Security are both super welcoming, open communities, and there are lots of folks far cleverer than I am. I think it's a great place actually to be if you want to contribute, because there are lots of opportunities to contribute that aren't necessarily focused on contributing code. And, you know, I know there are a lot of people who want to get more involved, but don't know where to start. And maybe, you know, they don't necessarily feel confident enough to be jumping straight into contributing code to a project. So the security community has lots of opportunities for folks to become non-code contributors in terms of contributing to writing or
no, that's the thing, because a lot of times when first timers are coming to us, they say like, hey, what are the prerequisites? I was like, the only requirement is to be a nice person and show up. Like that's it. Like nice. You don't need to do anything else as long as you have a smile and you're positive. Like that is it. Like you can spend years just going to SIG meetings and listening and meeting people and asking questions, and that's more than enough. So yeah, no, I think it's a really good point, is that both on the CNCF side as well as the Kubernetes side, tons of opportunities there. Jump into a SIG, get in the Slack, start asking questions. We are pretty much out of time, Matt, but we have a tradition in our community that every time we have a meetup, while we are talking, there is a secret hidden actor in all of this. Let me make sure that I got what I need. There we go. Let me go back to Zoom. I'm going to share my screen. And we have an artistic hacker. His name is Angel. And so let me know when you can see my screen. So while you were explaining all this wonderful information about vulnerabilities, Angel was creating an artistic rendition of some of the different things that were mentioned. Obviously, there was a lot of stuff that was there. And one of the key takeaways as well was in the very beginning, talking about the issue of vulnerabilities and then misconfigurations in infrastructure. I think you could probably write a book about that. But anyway, I think it looks nice. I like the pirate motif as well.
Yeah, no, it's great.
And anyway, like I said, we didn't get to talk about war games. We didn't get to talk about your record collection. Can I ask what kind of? I mean, I'm sure you listen to a little bit of everything, but what record do you currently have on your turntable?
So my collection is mainly techno and electronic music from pre 1992. So
okay.
I think the last thing I was probably listening to was some Joey Beltram for those folks who are into electronic music. From
all right.
Yeah.
Okay, that's cool. That's super. The thing is, it's wonderful because of having, like I said, we've done over 70 meetups. Everybody brings something different to the table. I have some homework to do now to look at electronic music. I'm assuming coming from the UK.
No, not necessarily. From Detroit. A lot of Detroit.
Oh yeah, because of course, most Americans don't know that the birthplace of house is Detroit and Chicago.
Yeah, so a lot of stuff from Detroit and a lot of stuff from places like Belgium.
Okay, very, very good. That's good. Do you DJ or you?
So I used to DJ. A long time. I used to DJ and run clubs.
Okay, yeah, but
for
I
about
think
15, 20 years. So yeah.
Do you ever do have you ever done like a live stream, like a boiler room kind of thing?
I haven't. No, I keep thinking maybe I should, but yeah.
I will promote you in any way possible. No, because I think it's really cool. But I think luckily now that we are going to start getting back to some like in-person events, there will be even more opportunities to
let's hope so.
To get the ones and twos rolling. Anyway, Matt, thank you very, very much for your time today.
Bart.
It was wonderful having you, and I'm sure we'll be seeing you again. And I fully support any application for any involvement more in the CNCF. So happy to help out there too wherever I can.